Hello everyone. So in last lecture we have seen this equation for prism I plus E is equal to A plus delta. Okay, we have seen this equation. Let me today I am going to derive the equation for delta minimum. Okay, delta minimum, or I can say today's task is derive equation for delta minimum. Okay, so today's task is derive the equation for delta minimum. So let me again draw this prism. Okay, this was the incidental ray, this was the refracted, and this was the emergent ray. Okay, now let me draw the normal over here. So this is the angle of incidence I, this is angle of emergence E, this one is I1 and this one is I2. This is the angle of prism, right? Okay. In last lecture I told you that when delta minimum is there, then I becomes E. Incident angle and emergent angle both are same when delta is delta minimum, and when delta is delta minimum, R1 is equal to R2. These both angle are same. These both angle are also same when delta is minimum. Okay. So now let me say that this has the refractive index N1. This has the refractive index N2. So I can write here for Snell's law. Okay, using Snell's law. What I can write? Eta 1 sin I is equal to eta 2 sin I1. Eta 1 sin I is equal to eta 2 sin I1, or N1 sin I is equal to N2 sin I1. Now what is I? See, if delta is delta minimum, I is equal to E. So from this I can write here. Okay, let it put bold. Equation number 1. For minimum delta, I plus E is equal to I is equal to A plus delta is delta minimum. So I can write here 2I is equal to A plus delta minimum. So I is equal to A plus delta minimum divided by 2. Right. Okay. And there was another equation. I hope you remember. Okay. The another equation was A is equal to R1 plus R2. જ્યારે ડેરિવેશન કર્યું ને આ ઇક્વેશનનું ત્યારે મેં આ ઇક્વેશન આવ્યું હતું A is equal to R1 plus R2. So I can write here for minimum delta A is equal to R1 plus R2, but R1 and R2 both are same. Let's say it is R. So A is equal to R plus R. So R is equal to A by 2. Okay. So I got R. Why I got this? Because I want to put the value in this equation. અહીંયા વેલ્યુ મૂકવી છે, ઇન્સિડન્ટ એંગલ અને રિફ્રેક્ટિવ એંગલની વેલ્યુ મૂકવાની છે મારે. ચાલો. So eta 1 or n1 sin I. Sin what is I? A plus del minimum by 2 is equal to n2, or I can say eta 2 sin I A by 2. Right? Okay. Now let me put this equation like this way. N2 by n1 is equal to sin A plus del minimum by 2 divided by sin A by 2. Right? Okay. Chalo. But for theta is for minimum theta, sin theta nearly theta. Okay. If theta is small, okay, or I can say for smaller, sin theta is nearly theta. So let me write it like this way. A plus delta minimum by 2 divided by A by 2. Okay, this is n to 1. The refractive index of 2 with respect to 1 n2 by n1, right? Okay, now 2 will be cancelled. A so 1 delta m by a. So this theta to 1. So delta minimum by a is equal to theta to 1 minus 1. So delta minimum is equal to a into theta to 1 minus 1 or n to 1 minus 1. This is the final equation. Okay. तो મિનિમમ ડેવિએશન નું ઇક્વેશન છે આવું. ઓકે, પૂછાઈ શકે હે ને, બહુ ઇમ્પોર્ટન્ટ છે, પૂછાઈ શકે. જોઈ લો એકવાર. ઓકે, શું કરેલું છે આપણે? derive the equation for delta m. So this was the question. Okay, so when delta m, I will become E. When delta is delta minimum, incident and emergent angle are same, R1, R2 and R same. Okay, using Snell's law, I want to find I want to find R1. So from this equation I found I, from this equation I found R. Put this value in this Snell's law. Sin is theta is very smaller, so sin theta nearly theta. Okay, and make the delta m subject of the equation. Okay, so delta m is equal to a n 2 1 minus 1. Clear? જોઈ લો એકવાર. Okay, chalo. Now આપણે બીજું એક ઇક્વેશન ડિરાઈવ કરીએ. Okay, derive the equation for, but I can say let me combine the lengths. Combination of lengths. Combination of lengths. Okay, now let us analyze the combination of lengths. Okay, let us get some equation for combined lengths. Let this length, this is a focal length f1. There is another length, let's say it is over here like this. Okay, this is the common principal axis. Both are on common principal axis. This has focal length f2. Okay, and this is the common optical center. Let's say બંને લેન્સ બહુ પાતળા છે, બોથ આર વેરી થિન. તો હું અહીંયાથી ડિસ્ટન્સ મેઝર કરું કે સેન્ટરમાંથી ડિસ્ટન્સ મેઝર કરું, અહીંયાથી ડિસ્ટન્સ મેઝર કરું કે અહીંયાથી ડિસ્ટન્સ મેઝર કરું, ક્યાંય પણથી ડિસ્ટન્સ મેઝર કરું બહુ ફરક પડશે નહીં. અહીંયા તો એવું લાગે છે કે ફરક પડે છે. સપોઝ અહીંયાથી હું આ ડિસ્ટન્સ લઉં, આ ડિસ્ટન્સ, અને અહીંયાથી ડિસ્ટન્સ લઉં તો થોડો ચેન્જ દેખાય છે, બટ એકચ્યુઅલમાં બોથ લેન્સીસ આર વેરી થિન, તો બહુ ઝાઝો ફરક પડશે નહીં. So all the distance will be measured from common optical point. So this is our common point O, right? Okay, chalo. Let's say I have an object over here. Let's say this is the object O. I want to find the image of O. First of all, let's say the object distance is U. Right? Okay. Now, there will be one ray like this. Okay. After the refraction from lens 1, it will go like this. It want to go like this way. I dash. Okay. It will go like this way. But અને આ I dash છે એનું ડિસ્ટન્સ કેટલું છે? લેટ્સ સે ઇટ ઇઝ V dash. આ જે ઇમેજ બને છે, આ ઇમેજ આ લેન્સને કારણે બને છે, ફર્સ્ટ લેન્સને કારણે બને છે. બટ જેવું આ રેઝ આમાં એન્ટર થાય છે કે તરત અહીંયાથી સેકન્ડ લેન્સમાંથી રિફ્રેક્શન થાય છે, અને રિફ્રેક્શન થતાં સીધું અહીંયા આવે છે અને અહીંયા શું બને છે ફાઇનલ ઇમેજ I. Okay, so this is the distance V. Okay, this is the distance V. Final distance V બન્યું. Okay, ચલો હવે we all know the equation of length. Okay, the equation for length. શું equation છે તો કે 1 upon f equal to 1 upon v minus 1 upon u. Right? Okay, chalo. So for length 1, the equation is 1 upon f1 is equal to 1 upon v dash. First ની ઇમેજ તો અહીંયા બને છે ને તો v dash distance થશે minus 1 upon u. What is u? U is over here, so it will be u, or I can let me write like this. Okay, ચલો હવે આ u છે એને આપણે સપોઝ અહીંયા છે આ સાઈડ છે તો આપણે એને માઈનસ u લખી શકીએ. ઓકે, તો માઈનસ u. ચલો ઓકે, for length 2 1 upon f1 is equal, sorry, f2 1 upon f2 is equal to 1 upon v. So 1 upon final image क्या है? What is the distance? V plus yes minus 1 upon v dash. जो first length ની જે image છે that will be behave as an object for second length. This image is object for this lens, second lens. Okay, આ જે ઇમેજ બની છે કોની બની છે? ફર્સ્ટ ની બની છે. તો પહેલાની ઇમેજ છે એ બીજાનું શું બની જાય છે? ઓબ્જેક્ટ બને છે. સો તો and this distance is plus, so let's say v dash plus. Okay, right? Okay, chalo. So what will we write? Let us do the summation of both the equation. Okay, equation number 1 and equation number 2. What we will do? Let 1 plus 2 karo. Chalo, 1 plus 2 karo. So this side 1 upon f1 plus 1 upon f2 is equal to 1 upon v dash minus 1 upon minus u plus 1 upon v minus 1 upon v dash. Right? So 1 upon v dash will be cancelled out. What is remaining? 1 upon v minus 1 upon minus 1 upon f1 plus 1 upon f2. Oh, मतलब के चलो आ इक्वेशन મળ્યું બટ સમજી લો બંનેનો રિઝલ્ટન્ટ આપણને ખ્યાલ નથી કે આ બંનેની રિઝલ્ટન્ટ ફોકલ લેન્થ શું છે એ આપણને ખબર નથી હે ને બટ આપણને એ ખ્યાલ છે કે ઇમેજ ડિસ્ટન્સ સોરી ઓબ્જેક્ટ ડિસ્ટન્સ ઇઝ u and final image is here, so image distance is v. તો આપણે એવું લખી શકીએ કે 1 upon f is equal to 1 upon v minus 1 upon minus u પેલી સાઈડ છે એટલે માઈનસ લખીએ છીએ એટલે ના લખો તો પણ ચાલે. ઓકે, તો we can write like this. So from these two equations 3 and 4, from 3 and 4 we can write 1 upon f is equal to 1 upon f1 plus 1 upon f2. The total, the resultant reciprocal of focal length is equal to reciprocal of first length focal length and reciprocal of focal length of second length. 1 upon f is equal to 1 upon f1 plus 1 upon f2. Let's say if I have another lenses, lens number 3, 4, 5, 6, then the equation will be 1 upon f3 plus 1 upon f4 up to infinite, and 1 upon f. Okay, you already know the reciprocal of focal length is equal to power. So the power is the inverse of focal length. So we can also write here like this, that P is equal to P1 plus P2 plus P3 up to infinite. We got the equation of power also. Okay, in the case of combination. Okay, so by combining the lengths power is increasing. આટલું તો ખ્યાલ આવે. ચલો, now what I can write? What is the magnification? For this case, magnification m is equal to v by u. Okay, now I can write here like this way: v by u, or v by v dash, or I can write like this way: v dash by u, v by v dash. See, v by u, v dash to cancel થઈ જવાના છે. So this v dash by u, v dash is here, image distance by object distance. This is the magnification of first lens, so it is tan1 v by v dash. This is the final image v. Object distance for second lens is v dash, है ना? तो શું થશે આ m to magnification of second. So m is equal to m1 into m2. तो magnification નું multiplication થઈ ગયું. Okay, by combining the lenses, magnification will be multiplied. Okay, now if the lens, there are so many lenses, then it will be m3, m4, infinite. Right? Okay, so this is the combination of lens. Okay, જોઈ લો એકવાર ઝડપથી. Speed. Okay, the image of first lens will behave as an object for second lens. So this is the general equation for lens. For first lens, for second lens, summation of these two, and compare this equation with this equation. So m is equal to power into magnification. Okay, all right. So આજના માટે આટલું જ. In next lecture we will discuss something more. Okay, ત્યાં સુધી એન્જોય કરો, રીડિંગ કરો. Thank you very much.